going to talk about electron orbitals. And remember that electrons are the smallest subatomic particle. They are circling around the atomic nucleus. And we can say the orbital is the area of space around the nucleus where the electron is most likely to be found at any given time. So electrons have this duality. They interact between different atoms because they are so far out from the nucleus. So if you can think of the nucleus as like an apple, the closest electron to the nucleus would be about a mile away. So when we have two atoms interact to undergo reactions, say, carbon and oxygen to form carbon dioxide, it's really the electrons that are doing the interacting. It's not the protons or the neutrons that are in the nucleus. So the electrons are attracted to the positive nucleus because the nucleus has the protons and opposite charges attract, plus and minus. At the same time, they're repelled by the other electrons. So the electron has this dilemma. It wants to be really close to the nucleus, but at the same time it wants to be as far apart as possible from the other electrons. So it's sort of in this constant battle with itself as it figures out the best placement around the nucleus and where it can be the most happy and the most stable. So electrons also possess energy, and it's the energy that is inherent in the electrons that causes reactions to occur between different atoms, making compounds like carbon dioxide or water. Electrons, like I said, move in these orbitals, a volume of space that surrounds the nucleus where the electron is most likely to be found at any given point in time. We're never 100% sure where that electron is, but we can say it's somewhere within this space. So each orbital, this volume of space, can hold a maximum of 2 electrons. So in an orbital you can have no electrons, you can have 1 electron, or you can have 2 electrons. And after 2 electrons, that third electron would go into a completely separate orbital. And again, that's due to the negative charge that the electrons have. Too much negative charge in one orbital would not be a stable configuration. Orbitals that are closest to the nucleus are lowest in energy. That should make sense because what does the nucleus have? Those positive protons that the electron is attracted to and wants to be near. We typically fill electrons from closest to the nucleus to further away from the nucleus. So you don't fill the outer ones in, you fill in to out. Atoms differ by the number of occupied orbitals. That should make sense because we said that each atom has a different number of protons, and the proton number is unique to that atom. Oxygen always has 8 protons, carbon always has 6 protons, and the number of protons and electrons is the same. So if oxygen has 8 protons, it also has 8 electrons, and that's different from carbon, which has 6 protons and 6 electrons. So atoms differ by the number of occupied orbitals, and if they have a full orbital, meaning 2 electrons in that orbital, that's going to be more stable than just having 1 electron. If there's an empty space in an orbital, that atom can interact with another atom and maybe grab an electron or share an electron in an effort to become more stable. So the orbitals have different shapes. These are some cartoon diagrams to illustrate that. The s orbital is sort of spherical shaped. P orbitals are shaped like dumbbells. There's also a d orbital that is pear-shaped. I won't ask you to remember any of these shapes. All I want you to know is that they have different shapes. What I'm going to do to try to simplify this orbital idea is group orbitals together that have similar energies. So all of the electrons that have the same energy, I'm going to put together and classify that as a shell. So we're going to group orbitals together into energy levels or shells, which look like this. Okay? So here we have some of the orbitals of the electrons. The lowest energy level, or the first shell, has 1 orbital, so it can hold a maximum of 2 electrons, and this would be the closest to the nucleus. On the next energy level, we have 4 orbitals that have a similar energy, so we can group them together and say that's the second shell. So if we have 4 orbitals, we can hold a total of 8 electrons in the second shell. The next level up is the third shell, which also has 4 different orbitals. These orbitals have similar energy electrons, so we're going to group them together and say that's the third shell. Again, with 4 orbitals, we can hold a maximum of 8 electrons. So in the first 3 energy levels total, we could put 18 electrons. So the shell model, again, is going to simplify, and it's going to be a way in which we can show how electrons are placed around the atom. And we're interested in that because if we can figure out how the electrons are placed, we can decide if that atom will undergo a reaction or not. The lowest energy is the first orbital. It can hold 2 electrons. The second shell has 4 orbitals and can hold 8 electrons. And the third shell can hold 8 electrons as well that are involved in bonding. Actually, it can hold 18, but we're only going to talk about the 8 that are involved in bonding because that's what we're interested in. What is going to bond? Here's an example of a shell model for carbon. And you're going to watch another video that talks about how to draw shells, but you can see carbon has 6 protons and 6 electrons. We put 2 electrons on the first shell. That shell is full, so we move to the second shell and we put the remaining 4 electrons. The second shell isn't full, so carbon could easily undergo a reaction. So if we want to determine if 2 atoms are going to interact and potentially form a molecule or create a bond, we look at the outermost shell, because those are the electrons that are going to be most reactive. They're furthest away from the nucleus. Atoms with incomplete outer shells are going to be reactive and undergo reactions, like oxygen and nitrogen here. Oxygen has 6 electrons in the second shell, so it's not full. It could hold 2 more. Nitrogen similarly has 7 electrons in its second shell and could hold 3 more electrons. So atoms are going to gain electrons, lose electrons, or share electrons to fill the outermost shell. And that's the basis of the chemical reactions we're going to talk about as far as bonding. So we're not going to talk about any of the atoms that already have a full outer shell because they're not going to undergo reactions.